Hello, sir, and everyone. My name is Mohammed Chughtai. In this video, I'm going to give a live presentation on my cloud computing assignment. Now, the first question that comes to mind is, what are we actually doing in this project? The answer is very simple. We are taking a simple Node.js web application, packing it inside a Docker container, uploading it to AWS ECR, and then running it inside a Kubernetes Minikube cluster on our live AWS cloud server. The main goal here is to show how we can deploy and manage an application automatically on the cloud. So, before checking the code, let's look at my terminal. A very common question comes to mind here. What is Minikube and why did it create a memory problem on our server? The answer is that production level Kubernetes is huge and needs multiple servers. Since we are testing this context on a single machine, we use Minikubes, which package an entire Kubernetes clusters into a single node. But the main issue is Minikube typically needs at least 1.8 GB of RAM to start up. Since we are using the AWS free tier T3.micro instance, we only have 1 GB of RAM available, meaning the server will normally freeze and crash. So to solve this limitation, I allocated 2 GB of virtual swap memory on the hard drive. So firstly we will go to our folder, which we can use cd space minus slash node minus app. Enter. So we will type free space minus app. So as you can see here, we allocated 2 GB of RAM. As you can see on my screen, this virtual memory act as a buffer, keep our server stable, and let us run Kubernetes completely free. So after doing this, let's test the live application now. I'm opening a fresh tab and entering over EC2 public IP address with port 8080. We will directly copy it from our instance here with security network. Networking we will go is the over public IP. We'll copy it here and paste it here with colon port, port number, which is 8080, and enter. As you can see, the custom web page is loading perfectly. Watch what happens when I refresh the page a few times. Every time I hit a reload, the server times update instantly and the visitor count increases smoothly without resetting back to zero. This proves our app is perfectly tracking user visits. If I would add slash health to the end of the URL, it gives a clear JSON response saying status up, which confirms our container is 100% healthy. So after checking this, we will lastly let's test the scaling feature of Kubernetes. We will go to the over again with over this one. We will type. I've already copied the command. I will just paste it. So to the command, just wait. Here is the command. We copied and paste and enter. So as you can see, deployment scale. The main question here is what happens if a website suddenly gets heavy traffic. The answer is that a single port might get overloaded and fail. To prevent this, we run the scaling command to increase our replicas to 2. Now let's check our workload again using 2-bit TN. As you can see on the screen, within seconds, Kubernetes initializes a secondary identical port. Now both ports will share the incoming traffic load automatically, ensuring high availability. So after doing this, to wrap things up, this project gave me a great practical experience with end-to-end containerization and cloud orchestration using Kubernetes as a standard safety practice to follow cloud governance and avoid any unexpected bills on my AWS account. I'm now running Minikube delete. Minikube delete in my terminal to clean up the cluster cache. Just wait some seconds, it will delete it. As you can see, the Minikube have been deleted. Right after this, I will go to my AWS console and completely terminate the EC2 instance to safely close all resources. So that concludes my presentation. Thank you so much for your time. Allah Hafiz.